Section 10.1, adding and subtracting rational expressions. We're on page 517. Essential question, how can you add and subtract rational expressions? Now remember, a rational expression just means a fraction. So anything that is written as a fraction is a rational expression. What do we have to have in order to add or subtract fractions? We must have a common denominator. The word excluded values, when you're adding or subtracting rationals, just means it's the same thing as the vertical asymptotes. You set the denominator equal to 0. Write that in your notes. Set the denominator equal to 0 to find excluded values. Now, to me, the hardest part about finding rationals or adding or subtracting rationals is getting the common denominator. So we're going to practice a little bit on just finding a common denominator. So let's say that 2x and x squared are our denominators. And we want to get a common denominator between 2x and x squared. So we want something that both of those denominators will go into. Okay, so first of all, let's look at just the coefficients, just the numbers out front. So I have a 2 and a 1. So what number will 2 and 1 go into? 2. Then I look at my x's. I have an x and an x squared. So what number will, or what will x and x squared both go into? They will both go into x squared. So 2x squared would be a common denominator of 2x and x squared. Let's look at this example. 2x minus 1. Now these are just denominators. We're practicing on just finding common denominators. We're not worried about anything else right now. Well, this is 2x minus 1, which all goes together. And this is x minus 6, and it all goes together. So I can't really separate those two. So my common denominator would be everything that's in both denominators. I've got to include everything that's in both denominators. Now this is not in your notes. This is just something you need to know, because we need to know how to find a common denominator before we can even start adding or subtracting rational numbers. All right, look at this example. This denominator is x plus 1. This denominator is x minus 6. And this denominator is x squared minus 5x minus 6. Now I have 3 different fractions. I told you before that this has to stay together. Well, this has to stay together. Now I have a trinomial here. What do I need to do to this trinomial before I can even look for a common denominator? I must factor this trinomial into 2 binomials. It will factor into x minus 6, x plus 1. So that is replaced with 2 binomials. Now let's look at our common denominator. So I have to look at all three of these. Well, I've got to include everything that's in all three of them. So my common denominator, I've got to include x plus 1 in it. I've got to include x minus 6 in it. X minus 6 is already there, and x plus 1 is already there. That right there would be my common denominator. It has that in it. It has x minus 6 in it. It has x minus 6 in it, and it has x plus 1. Just because these are repeated, you don't write them down twice. All right, one more example, and then we'll start working some problems. This denominator is x. This denominator over here is x squared minus x. What am I going to have to do to this denominator before I can get a common denominator? What do they have in common? They have an x in common. So what will that leave me if I factor out an x from this binomial? It will leave me x minus 1. So my common denominator, I have to have an x in it. I already have an x, and I have to have an x minus 1. That right there is my common denominator. All right, let's go back to the PowerPoint here. All right, adding and subtracting rational expressions. So I'm on page 519 up at the top. To write this problem in your Cornell notes, because I may work it a little bit different than they do in the book, I'll try to pick out the easiest way to work the problem. So we want to get a common denominator. So I have a fraction here plus a fraction. So I'm still going to have a fraction plus a fraction. First thing I need to do right here on this denominator, because I've got to find the common denominator before I start adding. So on this denominator, I'm going to have to take out an x, which will leave me x plus 1. So let's look at our two denominators. We have x squared, we have x, and we have x plus 1. I must have an x squared in my denominator, because that x squared has to go into my denominator. Now, the x will already go into the x squared. So I'm not going to add another x there, because x will already go into x squared. So I don't have to worry about the x. But then I have to add the x plus 1 as part of my denominator. Okay, so x squared times x plus 1 is my denominator. Now, I have to look at each fraction separately. So this fraction right here, I have to look at its denominator. I have to say how many times, or when it is divided into the common denominator, what is left. So if I divide that into this denominator, that will cancel my x squareds. What will I have left? X plus 1. So I must multiply my numerator by whatever's left. I must multiply the numerator by x plus 1. So up here I have x squared plus 4x plus 2 times x plus 1. Now notice, in my numerator and in my denominator, I have x plus 1s. So if I was to actually cancel those out, which they do equal 1, if I cancel those two things out, look what I have left. X squared plus 4x plus 2 over x squared. Isn't that what that says right there? Yes. So I really didn't change anything to this. I just added some stuff to it, which is equal to 1, which is legal. Okay, let's look at the second fraction. This one right here. So if I put x and x plus 1 into x squared, x plus 1, what is actually left over? Just an x. So I must multiply my numerator times x, or I can write it in parentheses like that. Any questions on that? Okay, so